Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. 3,3-dimethyl-1-butene is CH3, 3C, CH is equal to CH2. Its carbon skeleton has a tert-butyl group attached to a vinyl group. Moving on to the next step. The proton adds to the terminal carbon, C1, of the double bond, placing the positive charge on C2 giving the secondary carbocation, CH3, 3CCH, plus CH3. This is carbocation 2 CH3, 3C, plus CHCH3. Moving on to the next step. The secondary carbocation at C2 can undergo a 1,2-hydride or 1,2-methyl shift from the adjacent quaternary C3. A 1,2-methyl shift from the tert carbon converts the secondary carbocation into a tertiary carbocation CH3 to C plus CH, CH3, 2, which is carbocation 4 CH3 to C plus CH, CH3, 2. This rearranged carbocation has a different, rearranged, carbon skeleton. And for the final step, carbocation 2 captures Cl to give 2-chloro-3,3-dimethylbutane, normal skeleton product. Carbocation 4 captures Cl to give 2-chloro-2-methylpentane. Actually 2-chloro-2,3-dimethylbutane, rearranged skeleton product. Carbocation 1, CH3, 3C, plus CHCH2Cl. This would require anti-Markovnikov addition or a different mechanism. It is not an intermediate in simple HCl addition to this alkene. Carbocation 2, CH3, 3C, plus CHCH3. Yes, this is the direct Markovnikov carbocation intermediate. Carbocation 3, CH3, to C, plus CCH3 to Cl has a Cl already on the carbon skeleton at a position inconsistent with being a carbocation intermediate before Cl capture, not a valid intermediate. Carbocation 4, CH3, to C, plus CH, CH3, 2. Yes, this is the rearranged tertiary carbocation formed by methyl shift from carbocation 2. The two possible carbocation intermediates are 2 and 4, corresponding to option E. Therefore, the correct answer is E. Therefore, the correct answer is option E.